In this video, we are going to explore symbolic and hard links in Linux. We will learn how to create and manage these links using the ln command. Understanding links is crucial for efficient file management and system administration in Linux. Let's begin by understanding the key differences between hard links and symbolic links, also known as soft links. Hard links are direct references to the inode of a file. An inode is a data structure on a file system that stores metadata about a file, such as its permissions, owner, and location on the disk. A hard link cannot link to directories. Also, hard links cannot span across file systems. This means that a hard link must reside on the same partition as the original file. The file remains accessible until all hard links to it are deleted. Symbolic or soft links, on the other hand, point to the path of another file. Unlike hard links, symbolic links can link to directories. Symbolic links can also span across file systems, meaning they can point to files on different partitions. However, if the target file is moved or deleted, the symbolic link breaks, becoming a dangling link. Now let's see how to create hard links. The basic syntax is ln space, options, space, target, space, link name. Creating a hard link creates a new directory entry that points to the same inode as the original file. This means both files share the same data blocks on the disk. As a result, any changes made to one file will affect the other, since they both point to the same data. Here is an example. First, create a sample file. Use the echo command to write some text into a file named original.txt. Next, create a hard link to this file using the command ln original.txt hardlink.txt. To verify that both files point to the same inode, use the command ls-li original.txt hardlink.txt. The output will show the inode number for both files, and they should be identical, confirming that they are indeed hard links to the same data. Now let's discuss creating symbolic links. A symbolic link contains a text string that is interpreted as a path to another file or directory. Here is a diagram. The symbolic link, named symlink.txt, points to the original file, named original.txt, by referencing its path. The symbolic link has its own inode number, different from the original file. To create a symbolic link, use the command lns-original.txt symlink.txt. The S flag is essential as it specifies that you want to create a symbolic link instead of a hard link. To verify the symbolic link, use the command ls-l-symlink.txt. The output will show symlink.txt pointing to original.txt, confirming that the symbolic link has been successfully created. Remember, the S flag is crucial for creating symbolic links. Here are some useful options for the ln command. The S option creates a symbolic link instead of a hard link. The F option forces the creation of a link by removing an existing destination file, if it exists. The I option prompts for confirmation before overwriting an existing destination file. The V option prints the name of each linked file after it is created. The R option creates relative symbolic links, which are useful when the target and link are in the same directory or subdirectory. For example, to force create a symbolic link, use lnsftarget.txt link.txt. To create a link with confirmation if the file exists, use lnsitarget.txt link.txt. To create a link with verbose output, use lnsvtarget.txt link.txt. The output will show the link being created. To create a relative symbolic link, use lnsr/dir/target.txt link.txt. Now let's explore how to manage and identify links in Linux. To identify symbolic links, use the command ls-l. Symbolic links will be displayed with an L at the beginning of the line, followed by the link pointing to the target file. To check inode numbers, use the command lsi. This will show the inode number for each file, allowing you to verify if hard links point to the same inode. To locate all links to a specific file, use the find command. For example, find /samefile/path/to/file will find all hard links to the specified file. Broken symbolic links, which point to non-existent files, are often displayed in red when using ls color. Deleting a link, whether it's a hard link or a symbolic link, does not affect the target file unless you are deleting the last hard link to a file. Here are some more examples using find. To find all symbolic links in the current directory, use find. Type L. To find broken symbolic links, use find. Type L-. Exec test \print. To check if a file is a symbolic link, use the test command. Test L filename and an echo is a symlink. Let's explore practical use cases for both hard and symbolic links. For hard links, you can use them for backup and redundancy. Create hard links to important files across multiple locations without duplicating data, saving disk space. For version control, you can maintain different versions of a file while saving disk space by linking to unchanged content with hard links. You can save space by replacing duplicate files with hard links to a single copy, which is very useful for data deduplication. Symbolic links, on the other hand, are great shortcuts to directories. Create easy access to deeply nested directories from convenient locations using symbolic links. For system configuration, you can maintain multiple configurations by switching symbolic links to different config files. They are also useful for software management. Link to specific versions of libraries or executables without changing paths, making it easier to switch between versions. In summary, choose the right link type based on your specific needs and constraints. Hard links are great for saving space and ensuring data integrity, while symbolic links provide flexibility and convenience for accessing files and directories. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.